Let's work practice problem 14 on page 265 of your book. We're in physics, unit 8. So I'll read the problem out loud. It says, an 8-gram bullet is fired horizontally into a 9-kilogram block of wood on an air table and is embedded in it. After the collision, the block and bullet slide along the frictionless surface together with a speed of 10 centimeters per second. What was the initial speed of the bullet? So I've got the problem set up here. Here's our bullet. We don't know what its initial speed is. That's what we're trying to find. But we do know its mass. And then we know, the mass of the block here is 9 kilograms. And but it's an air table. That means there's no friction. We don't need to worry about frictional forces or anything. The bullet embeds itself in the block and they are moving at 0.1 meters per second after the collision. So we want to know what is this, and then just as an added bonus, I'm going to show you how much kinetic energy was lost, because that's the kind of question I'm going to give you on the test. I don't know why this problem in the book didn't ask for that, but oh well. So here we have a collision. So P initial equals P final. Now the initial momentum. Well, the block is not moving initially. So it's this. So it's just M1 V1 initial is equal to, well, these two things are moving together. So I'm going to say it's M1 plus M2 times V final. And we know what that is. So now it's pretty easy just to solve for it. So V1 initial is equal to the combined masses. 9 plus 0.0, so it's 9.008 kilograms. That's M1 plus M2 times V final, which is 0.10 meters per second, divided by M1, 0.008 kilograms. Kilograms cancel. So let's see what I get. You got 9.008 times 0.1 divided by 0.008, and I get 112.6, which I'm just going to round off to 113. Meters per second. That makes sense. The bullet's got to move pretty fast. Okay, so that's the answer. And let me check the book here. Make sure I did it right. Yeah, that's what the book got, so it must be right. All right, but now I want to add something on here just because physics is fun and problems are awesome, right? I want to figure out what delta K is. Well, delta K is K final minus K initial. Well, what is K final? It's 1/2 the mass times the final velocity squared minus 1/2 now this is M1 and 2 combined, 1, 2, and this is just going to be M1 V1 initial squared. So this is the initial momentum, final momentum, okay? So I say, all right, what's my final momentum? 1/2, let's combine the masses. That's 9.008 kilograms once again. And what's the final velocity? It was given to be 0.10 meters per second. We're going to square that. Minus 1/2 M1. Now, M1 is really tiny. But look at its velocity. And its velocity is big, really big. And we're going to square it, making it hugely big. And that's pretty big. All right, so delta K, let's see what I get when I do this. So 0.5 times 9.008 times 0.1 squared equals, and I get a measly 0.045 joules. So that's this guy. Minus Well, let's see what this kinetic energy is. 0.5 times 0.008, so that's pretty small, but times 113 squared. Oh my goodness, 51.1 joules. So if I go at 0.045 minus 51.1, I get, well, I lost, if I round it off to 3 significant figures, 51.1 joules. Negative. I mean, this, you subtract it, you can check it on your calculator, you get something that rounds off to this. Essentially, you lost all your kinetic energy. A little tiny bit left, but not much. Okay, now what percentage of our kinetic energy did we lose? Well, let's see. I lost I lost almost 100% of it, yeah. Well, we'll deal with percentages in another problem. But this is definitely an inelastic collision. Because we lost all our kinetic energy. Heated up the bullet, heated up the block, made a lot of noise. And so, that's the way it goes. And that is practice problem 14 with the little extra special kinetic energy stuff added in. Yay, clapping, thank you. That is all.